So the one thing which has magnitude as well as the direction, then it is called as a vector. And if it is having only magnitude, then it can be said as a scalar quantity. So example, if I consider scalar quantity, scalar, so mass is not having the direction, length it is not having direction, then area and the volume. So these are having only magnitudes. Magnitude means some certain value it is having the it is measured in the kg, length is measured in the kilometer or the meter, area is measured in centimeter square, meter square, and volume is measured in the liter or centimeter cube it is measured. So these are not having the directions, but in the vector they are having the these are the physical quantity which having the direction as well as magnitude. So if I take force, then I'm having the velocity and acceleration or momentum. So force is measured in the force, sorry, Newton, in terms of the Newton, but it is acting per meter square. The direction has been set. Velocity, if I take 30 kilometer per kilometer per hour. Kilometer is the measure of the distance, but per second or a per meter it is measured. Here also kilometer per second square I can take. So like this, it is having direction also. So that's why these are vector quantity. So it is having magnitude as well as direction. Okay. So what are the different types of the vectors? So here vector types of the vectors are unit vector. Unit vector. So when the vector whose magnitude is equal to 1, then it can be said as a unit vector. Unit vector. So that is the first one. So its a magnitude is equal to 1, is equal to 1. So vector is represented like this. I can say if I want to write a vector, then it is represented as a vector a. Like this, you have to write it. Okay. Then if I am writing the both vectors, if certain if it is there a and b, so if it is there, I can write this another AB vector. Okay, like this. If the magnitude, if I want to find the magnitude, so this is the vector representation. If I want to magnitude, then AB vector, magnitude of AB vector. So we have to call this one as a magnitude of AB vector. So this is only AB vector, and this is magnitude of AB vector. We can say. So here a vector now it can be represented as like this, a vector and magnitude of a vector. So this is the representation of the unit vector. Whenever in the problems if it is said it is unit vector, you have to represent like this, and its magnitude will be equal to 1. Then zero vector, second one is zero vector. So uh, whose magnitude is 0, magnitude is equal to what, 0, then it is called as a zero vector. It is represented as a, so zero vector is represented like this. We also call it as a null vector. Then third one is like and unlike vector. Like and unlike vector. So here vectors irrespective of their magnitude, okay, whatever it will be their magnitude, if they are have the same direction, then they we call them as a like vector if they are having same direction, and if they have opposite direction, then we call them as a unlike vectors. Okay. Fourth one, equal vector. Equal vector. So here two vectors are said to be equal then only if the magnitude and direction both are same. So if I say vector A and vector B, so magnitude is represented like this. Magnitude of vector A should be equal to the what? Magnitude of vector B. Okay, and the direction are also same, then only you can call them a equal vector. Then next comes here collinear vector. Collinear vector, the two vectors are said to be collinear if they are acting along the same straight line. Same straight line, if they are acting, then only you can call them a collinear vector. Then uh, sixth one is a coplanar vector. Vectors lying in the same plane, then only we can call them as a coplanar vector. Okay, then next initial vector. Co-initial vector, vectors having the same initial points are called as a co-initial vectors. So there should be a same initial point for them all, so we can call this as a co-initial vector. So these are having same initial point, that is O. Here are three vectors, 1 2 3, 1 2 3, but all of them are having same initial point, then we can call this as a co-initial vector. Okay, so with respect to the now let us see the position vector of a point with reference to the given point. So what is meant by position vector? So it is with respect to the given point. If I mention here this as a start point and vector is acting in this direction, so this will be a vector P. So this, if O is a reference point and the P is a given point, then OP this will be called as a position vector with respect to position. Sorry, that is a position vector of a point P. So it is of a point P with respect to the what? With respect to O. So it can be said like this. So here, so I hope you have studied about the different types of the vectors. In the next videos, we are going to see the problems and all.